plus 162 all over x meters squared. So guys, these are typical exam questions. Ne? I'm just gonna try by all means to pour my heart and make sure that I show you how to prove this. Ne? So one thing that you need to understand, before you can try to prove this, you must make sure that you simplify your diagram. So the first thing that we are going to do with regards to us proving this, we must find the borders outside the lawn in terms of x and y. We know that the sides of the lawn are x and y. So here, they actually gave us this x, and then they actually gave us that y. Do you get to see that? So when I'm saying we must find the borders outside the lawn, these are the borders that I'm talking about. Let me just highlight them. This one. We must find the borders outside the lawn, which is that. So what are we supposed to do now? It means to say, we must find the length including the outside border. So let's find that. So we're going to say length including outside border. Including sorry for my handwriting, length including outside border So the length including the outside border, it will be given by what? It will be given by x. It will be x. Remember, when I'm talking about the length including the outside border, I'm talking about this region. We want to find the distance of that entire length going to that direction, of which this will include you saying x, which is this one that I wrote right here, and then plus 1,5 plus another 1,5 that is going downwards. So that's one thing that you need to understand. But for the sake of those ones who don't see it, let me just try to draw it like this, or give you an insight like this. So it means to say we can see that that is the outside border, right? So that outside border from this green zone, which represent the lawn here, we are having that being what? We're having that being x meters. Then when you look at the red part going to the upside, we are given that as what? As 1,5. 1.5. It will be much easy when I'm showing you like this. As well as when you look at the red region downside, it's also 1,5. So it means to say, when I'm speaking about the length, including the outside border, I'm talking about the distance. That's why I was just trying to enlighten you to say, you know what, guys, this is the distance from here going to the downside. So that is our length. So it means to say it will be 1,5 plus x plus 1,5. So that's how you get it. So that's going to be your what? That's going to be your length. So even if you don't start by 1,5, you start by x, the way I wrote it, still correct. You are not going to be wrong. So it's x plus 1,5 plus another 1,5. So it means to say you're going to get the entire length of the lawn. Do you get to see that? So it's x plus 1,5 plus 1,5, of which, what are we going to get? Our length. Who can tell me the length of the outside border? What are we going to get? It will be x, and then 1,5 plus 1,5 is going to be 3. It will be x. So that x plus 3, it includes what? It includes the length including the outside border. So now we find the width including the outside border. So now I've just simplified the length part. So for you to get the width, you do it the other way around. So the width is the same as the breadth. So it means to say we are looking at the entire distance that I'm showing you, zone right there. Any question? So when you look at that one, the width or the breadth, it basically means to say we're gonna have the middle zone here being represented by y, as you can see from the diagram. That is gonna be our y. And then we are also having the sides, the length that represents the side on the other sides. So that's gonna be 1, as well as this one, that's gonna be 1. That's gonna be another one again, 1. Do you see, guys? So it means to say this will represent your breadth. So since now you have an understanding to say that will represent the breadth, you can actually say the width or the breadth, it doesn't matter. Width and breadth is one and the same thing. So let's rather use the width. So I'm just gonna say the width. I'm just gonna say the width including the outside border. Sorry for my handwriting. Width including the outside border. So the width including the outside border. Any question, guys? So that width, I'm gonna abbreviate it as W. Okay, the width is gonna be W. It's equals to. So since I've just elaborated to say the width and the breadth is one and the same thing, someone can say 1 plus Y plus 1. You're still gonna be correct. Or you just say Y plus 1 plus 1. You're still gonna be correct. Right? So our width or breadth is gonna be Y plus 1 plus 1. The next you can continue with that. It means to say that that's gonna be your width. It's equals to Y plus 2. Y plus 2. Do you get to see that? Because when you look at the question, they say, Mr. Dlamini wants to construct a rectangular lawn so that its area is 54 meters squared. He wants to plant flowers in the border outside the lawn 1 meters along. And then the part that I'm interested in that telling you to say, show that the area of the garden, including the border. That's why here, when you look at my calculations, I said the length including the outside border. Even here, this one is the length including the outside border. This one is the width including the outside border, right? And then after getting that, now we calculate the area including the outside border. Remember, this spoke about the rectangular field. Then it means to say you must know the formula of a rectangle. What is the formula of a rectangle, if I may ask? Area of a rectangle? Yakil, what is LB? L times B. What is that, Yakil?
Length times breadth.
Yes, length times breadth. So the area including outside border. Yes, you are right, Yakil. Thank you. I think it's Marcus Pellant if I heard you well. So you say area including outside border. Area including outside border. So now we find the what? Now we find the area. So since you understand that they spoke about the rectangular field and the formula for area of a rectangular field is given by area is equals to length times breadth. So you'll just say area is equals to length times breadth. Just like that. So we are not gonna struggle because now we are having our length being x plus 3. We're having our width or breadth being y plus 2. So it's a matter of you now substituting. So as easy as that, you'll say area it's equals to. So now when you look at our length, it's gonna be x plus 3. You write x plus 3 into our breadth or width, which is y plus 2. So we're gonna have that, right? And then one thing that you need to understand, let's go back to the statement. They spoke about something which is profound. They said Mrs. Lamin wants to construct a rectangular lawn so that its area. So you see now you highlight the rectangular lawn. Lawn is your key point. Né? They're saying Mr. Lamin wants to construct a rectangular lawn so that its area is 52 meters squared. It means to say now, they gave us a hint. When they speak about the lawn, they're speaking about that green zone that I've just showed you. You get to see that. Okay. So since they're saying Mr. Lamin wants to construct a rectangular lawn so that its area, So that lawn is represented by that green zone, and then it's a rectangle. It means to say the area of that green zone or the area of the lawn is gonna be what? It's gonna be given as like this. Let me do like this. So the area of the lawn, now I'm showing you the area of the lawn. Because the question here, it didn't want us to find the area of the lawn. The question, they want us to find the area of the garden, including the outside border. They want us to find the area of everything. So here on the side, I'm showing you how to calculate the area of the what? Of the lawn. So area, we know a lawn there, it's a rectangular field, hence it's gonna be length times breadth. Because that is the formula that denotes what? A rectangle. Length times breadth. Not only that, what are you supposed to do as well? You're gonna say area, it's equals to, you check your length. Remember, now we're gonna write the length of the lawn. The length of the lawn, length is the longest side. When you look at the green zone on the lawn, our length is represented by x, our breadth or width is represented by 1. So it means to say area, it will be xy. So area here, it will be xy, x times y. X times y is gonna represent our area. It's gonna represent our area. Not only that, and then when you go to the information given, they actually spoke about something which is very important that I want to pinpoint. They say Mr. Zlamini wants to construct a rectangular lawn so that its area is 54 meters squared. So they gave us the area. So it means to say in a place of area, you'll say 54. Right? So you'll say 54, it's equals to xy. Do you see now the important part? And then when you arrive here, you make y the subject of the formula. Remember, when you make y the subject of the formula, you divide by x both sides. Why do you divide by x both sides? Because let's say it's what you do on the left-hand side, you also do it on the right-hand side. That's one thing that you need to do. And then with regards to that, it means to say x cancels x. Here we're left with 54 over x. It's equals to y. Therefore, y it's equals to 54 over x. This question is a bit tricky, but it needs you to focus at the end of the day. So we can actually say that is our equation number 1. That's our equation number 1. Not only that, after getting that area including the outside border, we're gonna take that. Since this represents y, I'm gonna say substitute y into the area. Substitute y is equals to 54 over x. So how many marks is this question? It's around 7 to 8 marks, somewhere there. It's around 7 to 8 marks I kill. And then substitute y is equals to 54 over x into the area, into the what? The area. So the area that we are going to substitute onto, that is the area that we have here. So it means to say we're going to have area, it's equals to, now this it's x plus 3, you write x plus 3. So since now we are substituting that, it means to say, what are we going to write? Remember, this is y, and then here y is given as what? It's given as 54 over x. It means to say, where you see y, you write 54 over x. Let's write that, 54 over x. Then you add 2. That's what we are having here. We say plus 2. Then after that, you now simplify it, right? You now simplify it. So we're going to say area, it's equals to. So when I'm saying you now simplify it, it basically means to say you're going to use FOIL method. What is FOIL method? Multiply first. So let me just try to look at the space where I can just do a rough calculation. But this one, you do it aside on a script. So remember, when I'm saying you multiply, so it will be x multiplied by that 54 over x. 54 over x. You can see that x cancels x. You're left with 54. So you do this aside on a scribbler with a pencil. So that 54 is the one that you're going to write here. Gonna write 54. I'm just doing that aside. So this is your rough calculation. I'm just doing that so that you can be able to see. Because if I'm gonna calculation, because if I'm gonna just do it mentally, most of you, you'll be just confused. Ne? So after that one, we are done with that. Now, after multiplying those ones, you multiply what? The outer. So it will be x times 2. That one, it doesn't need explanation. It's going to be positive 2x. I hope you are following. And then after that one, we're going to multiply the inner, which is going to be 3 multiplied by what? 54 over x. So 3 multiplied by 54 over x. What is 3 times 54? I think that's 162, if I'm not mistaken. So it will be 162 over x. Let's double check. Let's double check. Where's my calculator? Let's double check. 3 times 54. 3 times 54. Yes, that's 162. So it means to say here you're going to write plus 162 plus 162 all over x. Just like that. Then after that, you multiply the last ones. So the last ones is 3 times 2. That one, it doesn't need explanation. It will be plus 6. It's straightforward. And then from that one, you now write area, you continue, right? So it means to say you're going to add your like terms, which is 54 plus 6. That's going to give you 60. Then we're going to write 60 plus, we're having 2x on the other side, plus 162 over x. So we'll write 162 all over x. Remember, when you look at that, go back to the question. We have proved that. You see, it's not difficult. When you go back to the question, check the question that I've just sent on the group. They're saying prove. Show that the area of the garden, including the outside border, is given by area. It's equals to 60 plus 2x plus 162 over x meter squared. Actually, this is the one that we actually got, this one. You can just write it properly, mathematical, so and say, therefore, the area, it's equals to, open bracket, still one in the same thing. You write 60 plus 2x plus, that's going to be 162 all over x. Close bracket, and then meter squared. Do you see? That's around 8 marks. You get all your 8 marks. So someone can ask me a question to say, sir, where is the meter squared coming from? Let me now explain. Remember, when you check the information given, they told us to say the area is 54 meters squared. And when we speak about the area, we are multiplying the length times the breadth from this formula. Length times breadth. Right? It means to say the length is given in terms of meters as well as the breadth is given in terms of meters. That's why when we now find the area, it will be m times m, which is meters squared. Because also from the diagram, we were actually given the SI units being what? Being meters squared. Do you get to see that? So as long as you're calculating area, it's going to be meters squared. So in an instance whereby they wanted you to calculate the volume, or let me rather say the perimeter, it was going to be meters. If they want you to calculate the area, it's going to be meters squared. If they want you to calculate the volume, it's going to be meters cubed. So those are some of the things that you must actually know. We are done calculating the first question. Those are the answers with regards to the first question. Now we are going to go to the second one. Any question? Any question?
No, sir.
Do you all understand?
So far, so good, sir.
Okay, sure. So now let's proceed. So these questions, you'll actually get them. Application of calculus. I was looking at the question paper for Free State today. Yes, sir. Sure. This is it. So of Free State, they didn't put anything. So I'm just going to check KwaZulu-Natal as well as Gauteng to see if we had something like this. But so far, the one that I've checked for Free State at June exam 2025, we didn't have application of calculus in a broader perspective. So it means to say, for prelim, high chances that you'll get these questions. KZN my home, show Yakil. So on number 2, they're saying if A is to be as small as possible, find the dimensions of the larger rectangle. Then I normally like to emphasize this on the sessions. I normally like to say when you deal with calculus, for you to be able to get a hint to say now you need to differentiate. So when you look at the second question, 5.5.2.2, it needs us to differentiate the area. But how do I know that it needs us to differentiate the area? Now I'm giving you the hints. Whenever you come across whenever you come across maximum in calculus, you must always differentiate. Whenever you come across minimum in calculus, you must always differentiate. Whenever you come across as small as possible in calculus, you always differentiate. Whenever you come across as large as possible, you also differentiate. So let me repeat the question. That's it. If A represents area, to make that clear for you. So if area is to be as small as possible, now I've given you the hints. As small as possible, you differentiate. But the question comes, what do you differentiate? You differentiate the area. That's why the previous question, they wanted us to prove the area first, so that now you can differentiate it. Do you see? Find the dimensions of the larger rectangle. Do you get to see that? So let's write our area. So our area, we get it. We got it. And this question is intertwined into two. They're saying if area is to be as small as possible, find the dimensions of the larger rectangle. It means to say we're going to differentiate in order to find the dimensions. What are the dimensions? Or what do we talk about when we speak about dimensions? Dimensions, we are speaking about the length or the distance, right? So here we actually got 60 plus 2x. Do you get to see that? Plus 162 over x. So before you differentiate, we're going to change that 162 over x. We write it in an exponent form. So it means to say this is one and the same thing with you writing it. Because the reason why I say we want to change it and writing it in an exponential form is for us to be able to differentiate. So that is going to be 60 plus 2x. Then 162 over x is the same as plus 162 x to the power of negative 1. Then now you differentiate. So a prime is equals to 0. At any turning point, a prime is equals to 0. And then let's now differentiate. So we are differentiating a with respect to x, dA, dx. Some of you have come across this. When we say dA, dx, it means to say we are differentiating a with respect to x. To those who are going to go to university level or college level, whenever you're going to do, let's say, engineering or any course that has to do with you majoring in maths, there is a topic called integral calculus or integration. Integration is a continuous of calculus. And here is differential calculus. Then you'll get integration. You'll actually see what do we mean when you speak about integration. But for now, let me just be at your level. So the other thing that you need to understand, now we are differentiating. The derivative of a constant is 0. I'm going to show you on sessions to come to say why do we say the differentiation, the derivative of a constant is 0. I can prove that for you. It's still going to be correct. It's very easy. So that is 60. So the derivative of a constant is 0. So we normally leave it, right? And then let's derive 2x. 2x, when you derive it, you're going to get 2. Because remember, it's going to be 2x to the power of 1. You always subtract 1. And then positive times negative. So it will be 162 times negative 1 is negative 162. Negative 162. X to the power of, we write negative 1. They say you must always subtract 1. Do you get to see that? Now, let's resolve that. So this is going to be 2. Anything to the power of 0, because this will be x. 1 minus 1 is 0, right? Sharp. Minus 162. And then that will be x to the power of negative 2. Look at this. This is going to be 2. Anything to the power of 0, the answer is 1. So there was no need of me writing it. I was supposed to just write 2, but I wanted to show you something. Minus, so that's 162 x to the power of negative 2. So you can write it like this. That would be 2 minus 162 x to the power of -2. Then remember, a prime is equals to 0. It means to say here we must write 0, we must also write 0 in order for us to just solve. So now, let me write it properly. So that's going to be 0. It's equals to, so this is 2 minus, so 162 x to the power of -2 is the same as 162 over x squared. Then since now we can see that it's negative, you transpose it to the other side, it changes the sign to become now positive. So it means to say you're going to have 162 over x squared. Now we are solving. It's equals to 2. When it's like this, you give it to a grade 9 learner and you say solve for x, cross multiply. Remember, this is over 1. So 2 times x squared, that's going to be 2x squared. It's equals to 162 times 1, that's 162. And then you divide both sides by 2, because math says what you do on the left-hand side. So do it on the right-hand side. 2 cancels 2. X squared, it's equals to, let's now solve. 162 over 2, you're getting 81. 100%. 81 is a perfect square. We must get 9, whether you like it or not. X squared is equals to 81. Introduce square root. Introduce square root, plus minus. 2 cancels square root. X is equals to plus minus the square root of 81 is 9, because 9 squared is the same as 9 times 9, it gives you 81. And then with regards to that, you know that length, distance, it can never be negative. Therefore, the only answer which is positive, the only answer which is correct, so to say, is going to be 9. So it means to say 9 is going to be 9 meters. You know why? Because distance, it can't be negative with regards to that. So it means to say, since they say, find the dimensions of the larger rectangle. The dimensions are the ones that I actually told you to say you're going to find them like this. Now it means to say you must go back to the previous dimension where we spoke about the length including the outside border. So if you go back up there, the length including the outside border, to save time, we got what? We got x plus 3. Do you still remember? We got x plus 3. This basically means to say, since it's x plus 3, our length including the outside border is going to be equals to, you ask yourself a question, what is the value of x? It's 9. So it's going to be 9 meters plus 3. Therefore, the length including the outside border, it means to say it's going to give us what? 9 plus 3, 9, 10, 11, 12. So that's 12 meters. Do you see how we solve that? Welcome to application of calculus. Not only that, and then now we find the width. Our width or breadth, we go up there. I've showed you to say the width, we got what? We got y plus 2. Y plus 2. But mind you, there is somewhere where I wrote equation number 1, if you still remember. I wrote equation number 1 somewhere. So that equation number 1 that I wrote, it means to say we're going to take it. I wrote equation number 1. There is somewhere where we got y is equals to 54 all over x. Then now, for you to get y, you'll say y, it's equals to 54. It's kind of like you say, substitute x equals to 9 into equation number 1. So we are having 54. All over our x, you can see it's 9. Let's find the value of y. Therefore, y is equals to, what is 54 over 9? Let's see. 54 divided by 9. That's 6. We got 6. So you're going to write 6 here. So since that is 6 meters, that's not your answer. Yes. Now you go to the width. Remember the width, you'll just say width, it's equals to, that's y plus 2. So our y, we got 6. So you'll say 6 plus 2. Do you get to see? The final answer for the width is going to be 6 plus 2. It's going to be 6, 7, 8. So it's 8 meters. As easy as that. So this is how you find these questions. So the dimensions of the larger rectangle are, the length is going to be 12 meters, the one that we got here, as well as the width or breadth is going to be 8 meters. So that is the tricky part about this question, but I've just showed you the insights on how to solve this. For you not to struggle, it means